Alright, Assalamualaikum warahmatullahi wabarakatuh. Maybe good morning. I don't know, maybe good morning or good afternoon or good evening to all of you. Previously we learned about metals reaction with oxygen. Okay, as you can see from the examples, um, the metals reaction, okay, with oxygen, you can see from the magnesium being burned, all right, and giving a white flame, a brightly white flame. And you can see from the reactions, the iron rusting process, okay, the rusting process um, is the reaction of the rusting process is caused by the reaction of metal with oxygen. So today we're going to learn about metals and periodic table. Okay, in this topic we will learn about the reactivity of the metals, and we focus in group 1. Okay, group 1. Okay, so guys, I told you, right, so we start here. This is group 1. All right, group 2, this is the transition metal group. Group 3, 4, 5, 6, 7, and 8. All right, okay, so this is what we call period. Period 1, period 2, period 3, period 4, period 5, 6, 7, and so on. So don't focus this thing, all right? This thing is not important, okay? This is the, what they call, another series, another group, so don't focus on this unless if you want to take chemistry degree, yeah, you need to know this thing. But for now, just focus here, okay? So let's see metals and periodic table. So from this periodic table, the metal is blue color. So you can see from this periodic table, most of the elements in the periodic table are metals, right? Metalloid is the green color one: boron, silicon, germanium, arsenic. All right, what is this? What is this? Antimony, tellurium, and stuff like that. Okay, so these we call metalloid elements. What is metalloid elements? It has half of the property of the metal and half non-metal property. So it's like combination for both metal and non-metal. For example, you look at silicon, all right? Silicon cannot conduct electricity, so it is under non-metal. It cannot conduct electricity, and it's not really a good conductor of heat, all right? So it's under non-metal, but it is hard. It's quite hard. So it has the properties of metal. So that's why it is in metalloid group. Okay. So the the yellow color are the elements of non-metal. So most of the non-metals are metals. Each of the elements has different atomic structure with a different number of electrons, protons, and neutrons. The atoms of different elements are different size. Okay, so you know this is different size. Lithium is different size from beryllium. Beryllium is different size from boron. Boron is different size from carbon. Okay, the atomic size is keep increasing down the group. You have learned this before. It also increasing across the period. Alright, so the lower the elements in the periodic tables, okay, the larger the atomic numbers and the larger the size it has. Okay, so metals have some properties in common and some properties that are slightly different. For example, iron is hard and strong, but sodium is much softer and can be easily cut with a knife. So even in this even in this metal group, each of the metal might be a little bit different from each other. So like here, where is iron? Where is iron? What we call iron? Ferrum. This is iron, right? Ferrum. So ferrum here is very hot. Okay, usually the transition metals in transition elements are hot. All right. How about here? This is sodium. Na, sodium. Okay, sodium is very soft. You can cut it with a knife. Okay, and you need to store it under oil. Okay, you store it in a beaker containing oil. Why? Because it's very reactive. So this group we call alkali metals. This we call alkali earth metals. So both of these alkali metals and alkali earth metals, both groups, there are soft metals. Okay, basically the most soft metal is lithium, sodium, potassium, rubidium, calcium, and francium. But don't bother about this rubidium, calcium, francium. Just know that lithium, sodium, and potassium is these three are soft metals. Okay, hydrogen. All right, how about hydrogen, teacher? Hydrogen is non-metal. Right, so you can see from this color is in yellow color, so it is not non-metal. So uh, non-metal, but why is it's in the first group? It's kind of special actually. Okay, so it actually not belong to any group. It's just above this group 1. Understand? So what else? So transition metals usually hard. Okay, hard metals. Okay, it's hard to cut ferrum or copper with just a knife, right? Okay, let's see next. So reaction of group 1 metals with oxygen. So you can see here group 1, please ignore this hydrogen group. Yeah, it also in group 1, but it is special case. So lithium, sodium, and potassium. No need to focus on rubidium, calcium, and francium. So group 1 elements we call alkali metals. So here included in the group 1 of the periodic tables are the following elements: lithium, sodium, and potassium. Okay, so the metal in group 1 of the periodic table are softer than other metals and more reactive than other metals. That's why it needs to be stored under oil, because they react vigorously with the moisture of the air and can explode. Okay, so I highlight over here. That's why you need to be stored under oil. Okay, because it reacts vigorously. So the reaction, okay, right. So the reaction of alkali metals with oxygens, when pieces of lithium, potassium, or sodium are taken out of their containers, they appear dull. And when the pieces are cut, the surface is shiny, but it soon becomes dull because the metal react with oxygen in the air and give you oxide metal. So first you take it out and then it dull. All right, it is dull. And then you cut it, you can see the surface is shiny. Okay, but that shiny surface become oxidized. When I say oxidized, means that oxidation state has happened, means that it react with oxygen and it produce metal oxide. Okay, so metal plus oxygen, it will produce metal oxide. Understand? This is the equation, the word equation that you need to remember. Metal plus oxygen, it will produce metal oxide. Okay. So next, these are the questions that you need to answer. Name 2 metals that have atoms larger than those sodiums. Which property of sodium is not typical of metal? So typical of metal, usually when you say metal, it is hard. So what about sodium? So suggest why it might be difficult and dangerous to test sodium for electrical conductivity. Why? I don't know. So write the word equation for the reaction sodium with oxygen. So metal plus oxygen, it will become metal oxide. Alright, that's all for now, guys. Please do the questions in your exercise book. If you don't have your exercise, if you don't have the exercise book with you, please do it in a piece of paper. Okay, please, and please copy down the questions. Okay, that's all for now. I hope you have a nice day. Alright, love you. Bye bye.